Hello, this is Dave Tassi, Senior Strategic Account Manager from NSK Americas, to provide you an anti-friction bearing presentation with materials provided by the BSA. Bearing basics. Bearings have developed from three basic types: plain, ball, and roller bearing. Plain bearings, or friction bearings, are non-rolling element. They are also called sleeve bearings, and they can be made of bronze, wood, plastic, or many other materials. Anti-friction bearings. Anti-friction bearings use rolling elements. They could be ball, journal, needle, or a variety of rollers. The purpose is to reduce friction, to transmit loads. Those loads could be radial, axial or thrust loads, or a combined load. They also support and locate the shaft in mechanical systems. Types of rolling element contact. Ball bearings have a point contact, which allows for higher speeds. Rolling elements have a line contact, which allows for higher load, but lesser speeds. Bearing loads are either in the radial direction, which is perpendicular to the shaft, in the axial direction, which is parallel to the shaft, or in most applications, you will see a combined load of various degrees of radial and axial loading. Anti-friction ball bearings consist of an outer ring, an inner ring, rolling elements, in this case, steel balls, a cage to separate those elements, and then generally some sort of shield or seal to keep the lubrication in and the contaminants out. Again, the ball bearings produce a point contact and are able to accept combination loads. For anti-friction journal roller bearings, there is again a line contact, but primarily only can accept radial load. And a journal roller bearing is defined by a roller length between 1.4 and 6 times the roller's diameter. Now for anti-friction needle roller bearings, again, you have a line contact and it can accept only radial loads, but that roller length is over 6 times the roller diameter. Anti-friction cylindrical roller bearings, again, produce line contact and are primarily for radial loads, but you have a roller length not exceeding 1.4 times the roller diameter. For anti-friction spherical roller bearings, you have line contact, and they are able to accept a combined load due to the geometry of the roller and the design of the bearing itself. Anti-friction tapered roller bearings, again, produce line contact and can accept combined loads, even greater axial loads than the spherical roller bearings. Now, application factors to consider when you're designing a bearing into a system is the loads. Do you see mainly radial? Do you also see axial? Is there a combined load? Very important in the choice of the type of bearing for your system. Know what the speeds are, generally in revolutions per minute. Know how hot an application will get. Depending on the temperature, you may have to use special materials or special bearings to accept those temperatures. Know how long you want that bearing to last. There is just a myriad of applications in the world. Some only need, 100 hours of life. Some need thousands of hours of life. Know that, because that is very important when an engineer will design a particular bearing into the application. And then in the aftermarket, know if you just want to replace what is already in the application. So you would read the part number on it and ask for that exact replacement, or know if you want to upgrade your application. For many instances, the bearing that was designed initially is not capable to handle the life or the loads that you're putting on that bearing, so you may want to upgrade. And that is something to consider when you are designing or replacing a bearing in a system. As you can see, there are many choices and styles of bearings for the myriad of applications in the world. Please use this tutorial next time when choosing the right bearing product. Thank you.